Okay, I'm going to try to do some coding with Langchain. Okay, this is a framework, very powerful framework, Langchain project. Let's start with the from start. I created a folder and I'm going to open CMD here, and we can install UV. Okay, to install UV you can use UV package manager. You can go ahead and do it from here, UV package manager, this one basically. You can go ahead and choose, if you're using Windows, you can just copy this one and paste it here. Okay, but in our case, this is 1 second, let me open CMD here and I will run it as an administrator. Since I already installed it, I don't want to do it again, so I'm just going to go to the path cd, and first thing I will do is UV init, just to initialize. So basically I want to create a virtual environment now. So second, I want to create a virtual environment which I will use UV, V and V. So this is the virtual environment, and I will open this one here. Okay, and second, once you create a virtual environment, so now we can create a new file here, requirements.txt. Add Langchain community, and yeah, Langchain, let's say OpenAI, because we'll be using OpenAI as well, and Langchain Grok, Python .env, Langchain, Google GenAI. So save this one, and next thing, we just want to install those requirements. So we'll do UV requirements.txt. No, this is not the right way actually. You're supposed to do UV, then add -r requirements.txt. No solution found, resolving dependency because Langchain community was not found in the package registry. I think it's the spelling actually. This is not the right spelling, that's why. Community, and save this one. So I'm just going to do this one. Yeah, so now it's working. So it has just installed all my libraries. So this is why we need to use requirements. And then we can check the version. If you go to this pyproject.toml, you can check the version from here of each one. Okay, you can compare with yeah, you can see if it is the latest version or no on this pyproject.toml. So next we have to get the API keys, and first let's create a new file here, .env. so we can copy and paste our API keys. So for Google AI API, let's go ahead and do this one. Okay, Google AI Studio here. Okay, but we want API keys, right? API keys. So you can just go ahead and do this one, and you can just check here. You have to make sure to access this site, AI Studio, and you can just create API keys here. You can create a project if you haven't already created. So I'm just going to create any project here, and choose the imported, then create a key. And this is the API keys. Okay, so I just copy the API keys, and which I will remove after I do this. So then you have to paste it here first for now. Okay, and now that we've created an API key, yeah, so what is next? We have to do the same for but we have to check first where exactly I'm going to put this API keys. Like we have here quick start, the naming, how we're supposed to give it the name for this. So it's already giving you the key here, the API keys. So the API keys for Google AI, we're supposed to put it like I think Gemini API keys, like this. Yeah, so we're supposed to make it like this, I think. Gemini API key. So let me just paste this one, paste it here, and yeah, Control X equals 2, yeah, and that's it. And they are giving you instructions actually on how to, they're giving you quick start here, how to use it. You can install it using this command for Python, and we can use this one. Basically we're going to import Google import client, and so this is it. Using tools, it's even showing you how we can do it using tools. Okay, yeah, so now let's go ahead and do the same thing with Grok. Basically Grok API keys, and yeah, let me sign in because yeah, I already have an account in Grok. Any organization, make sure the email address is correct. I can try a different okay, I think this is not the one second. Actually let's postpone the Grok installation because we'll use it later on. Okay, no, right now we don't need it, so we just need Google AI. So next step is actually we need to install the IPY kernel. Okay, uv-add IPY kernel. Basically the uv-add is used if you have independent libraries you want to install. You can just use uv-add. Okay, once this is installed, we are going to use something called Jupyter Notebook. Okay, and the name stand, yeah, so basically it's an interactive Python notebook. Okay, so we can write code okay, whether it's Python or anything, or R or Scala, and run it and see the results immediately. That's the main benefit of this one. Okay, to make it very easy for us to see the results immediately. So to create this is very simple. Okay, let's create just a new folder here. Okay, we can type Langchain or whatever, and you can create whatever here, one or whatever you want to create here, the name. Important is the extension. It has to be IP YNB. Okay, like this. Okay, and this is what how it should be. Okay, just wait for it to finish. Failed to install IPY kernel. Access is denied, but I'm using a administrator. How is it access denied? Okay, let's generate, for example, here. Okay, I think it's working. You can click generate, and then you can select the kernel. Enable suggested. Select the kernel. Install. Enable suggested extension. Python. I think we will choose Python now. Python environment, yeah. So it will install our extensions and everything. Yeah, so we will choose installing the Python extensions. Then we have to choose Python environment. Then our this is our virtual environment that we're using. I think that's all we have to do. Okay, to create this. Okay, and then we want to test something. Okay, this is I don't want to use OpenAI. I want to use okay. So I want to explain something actually, the difference between GenAI and basic agents. So let's go ahead and before we move on, let's just open this one, ScaleDraw. Okay, move on to the. Okay, so let's say before this is an LLM. Okay, this is basically an LLM. Okay, and we have here the this is the output. So this is the input. This is the output. Okay, and we have this, and we have this one. So this is GenAI. GenAI. Okay, so the idea is whenever a user sends any text here, input, asks any question or whatever, like here, let's say, what's the capital of France or something like this, right? This is a question. This is the user asking the LLM, whether it's ChatGPT or whatever. Let's assume this is ChatGPT. Okay, and this is basically the output, the response of this. So the answer is going to be Paris, right? The capital of France is Paris. So this is what they mean. So what happened when we asked the question? The LLM just checked. Okay, and it has the answer, so it knows the answer, so it gave you the response. So this is basically generative AI, what we call generative AI. This is a basic generative AI. Okay, so not an agent. Okay, so let's say we want to check now. We want to make an agent. Okay, so let's say we add here something else. We call it tools. Okay, so let's say the tool can be anything. whether it is let's assume here anything, it doesn't matter. Okay, so okay, now let's change the question. Okay, what's the weather what's the weather today in Saudi Arabia? Let's just make this assumption. Not let's be specific. Let's say New York. Okay, it doesn't really matter. Let's just say New York. Okay, so the LLM doesn't know. It's not trained up to. There is a cutoff date, right, for the LLM, so it doesn't know what the weather is like today. So it's going to be connected to multiple, to the Google search, for example, tool, internet, or weather API. Weather API. Okay. Weather API, and it might be connected to Wikipedia. This is what we call by tools, basically. Or it might be connected to, let's say, some news article like CNN or whatever. Yeah. Okay, so what it's going to do, it's going to check. So since it doesn't know the answer, it's going to decide, and it's going to say, I'm going to check with the weather API, or Google. I'm going to do a Google search. Then it's going to reply to you here with the response that it got from the tools, not from its own data. It's going to give you the weather in New York. New York is sunny today. Okay, and this is not now this is no longer a generative AI. Okay, this is what we call a basic agent. Okay, so now we've moved from just generating, since we just added tools to it. Now we gave it now we started calling it a basic agent. This is the difference between these two. Okay, and next, I don't want to do this example actually. I just want to go straight with the test actually. Okay, so I want to go ahead and do this. First thing, actually, we are supposed to import OS. Okay, no, this is very fast. Okay, generate code. No, remove this one. Just right here, import OS. Okay, down from .env. So we will get access to the we will load the .env. So will give us access to .env, and then actually I want to access Gen AI. So I'm going to check the documentation, or yeah, for ChatGPT we use this one. And let me go ahead and try this one. Okay, let me go to the Google AI. This is not the browser. 1 second. This is the one, I think. Yes. So let me go ahead to Google AI Studio. Okay, this is the one, I think. Here we got our API, right? So let's check the quick start here. Okay, so let's assume that we want to try this model. Gemini 3.5 or whatever. Okay, so I'm going to go ahead and try this one. First I'm going to import from Langchain. Let me just go down here from Langchain dot chat models. Okay, import init underscore chat underscore model. Okay, so now, okay, I'm going to say agent or whatever. This is just a name. Okay, I'm going to use init chat model and Gemini. You don't need to do that. Let me just move this here. Okay, close this one. Okay, and right now I'm going to type GPT, not GPT, just type the agent. Okay, dot invoke what is the capital of France? Yeah, this is a good example. Okay, so yeah, so it doesn't have to be agent. You can name it LLM or whatever. Yani this is just a name. Okay, invoke is what we use to answer. So now let's execute it. Okay, let's just click enter, execute this one. Okay, run all or whatever. Now we got an error. Initializing chat vertex requires Langchain. Yeah, init underscore chat model. Init underscore chat model. Let's LLM equals to. Okay, let's install this one, this library. Okay, let's just go ahead and do it. Okay, Langchain UV add Langchain Google Vertex AI. Please install it with pip install Langchain. Okay, I installed this one. Okay, now let's go ahead and run it again. Okay, I think I'm doing something wrong here. Okay, so this is the first time I'm using Google AI Studio. Actually, it might be that. So let's use our OpenAI for our example. Okay, let's just use OpenAI since that's what we are going to use anyways. So let's just use the OpenAI API. Put here. Yes. So right now, yeah, so what I just did, okay, I tested, now it's working. Okay, I did some extra stuff here, like I added OpenAI and Grok also in .env. And first thing, we need to make sure, first of all, that the model actually exists. Okay, you can do that by checking their website. Their this time Google models here, you'll see for each website, and you can check it here. And then you have to provide the model provider, which is OpenAI in our case. It can be Google as well. I tested with Google, it works. Okay, so let's start to go through it one by one. So I said here import OS. The reason we said this, we use this one, is like to import Python's built-in modules for interacting with the operating system. Okay, so basically in our case, it's used to read the secret in the API keys from your environment variable. That's the purpose. In order for it to be able to read the .env file, we have to use this one. Without this, it won't work. Okay, and from .env import load.env. This is we're just importing the library .env. This is the library that we will use to call to load the env files, right? So then we have to call it here, load the underscore .env, looks for a file named .env in the project file. It reads the key value pairs inside the file, like Google API keys, and loads it into your system environment variable, so Langchain can securely access them. That's the purpose of this command. Okay, then we have to run this command. Okay, from Langchain chat model, import init chat model. This imports init chat model, which is Langchain's unified standard function used to initialize different AI model without needing to provider specific import code. This is very important. Okay, if we don't use this one, because we are this one, you can use it. You can use it with OpenAI. You can use it with Grok. You can use it with whatever, Google. All they can. It makes it easy for us. Okay, like here we're just declaring any variable here, LLM, and this is the one init chat model. Here we define the model, GPT-5. Here the model provider, which is OpenAI. This is just to make the output accurate. That's it. Okay, and then we're declaring another variable, and then we're invoking. LLM.invoke means we're just sends your text prompt to OpenAI API and waits for the model to generate an answer. That's the job of this command. Okay, then we use print response.content. We just want that response. That's why, because if you use just response, there will be too many stuff that you don't need. Okay, so there is another way of doing this. Okay, like this one. Here we use the same from .env import load.env, right? But this one is new. From Langchain underscore OpenAI import chat OpenAI. Okay, then we use chat OpenAI, LLM equals chat OpenAI, and then we put the model. We define the model equal to this, and this is the difference. Okay, remember, yeah. So here we use init chat model. Okay, here we use specific. This is specific only for OpenAI. Okay, if you see the definition here, we use init chat model, which is Langchain's unified standard function used to initialize different AI model without needing provider specific imports. So this is basically provider specific import. If this was let's say Claude, Anthropic, or Gemini, we'll have to use this one. From Langchain import chat OpenAI. This is one we use for OpenAI, and for Google AI or Gemini, we have to use this one. From Langchain Google Gen AI import Google generative AI, and for Anthropic or Claude, we have to use this one for Langchain Anthropic. So this is it. This is all provided specific imports. Okay, but instead of using this, we chose to use the import given built-in import to simplify it, we use init chat model. So now if I want to change this to Gemini, all I have to do is just change this one, Gemini, it was 3.5 I think, okay, and then it was Flash, okay, and all I have to do is change this one to Google Geni _Gen AI. That's all. Now if I type this, okay, I'm just going to get the answer. Let's test it. Yeah, so the answer is it gave you here the capital of France is Paris. That's it. So it worked. You see if you understand the concept, it worked because this is a unified import. It's very useful. So all I did is change this one and it worked. So this part we understand, and yeah, so let's finalize this. Okay, so a few things we want to try first. Okay, I'm going to do it from scratch. Let me remove some of these things. We don't really need it, or remove it. Yeah, so let me do an application from scratch. Okay, because I want to talk about some things. Okay, so I'm going to go ahead and first I'm going to from Langchain, let's do chat _ models import init chat model, and let's go ahead and create LLM here equals to init _chat model _model, and open this one, and we're going to define the model here, which is equals to GPT-5. Okay, and we're going to also define model provider, and our model provider is going to be OpenAI, obviously. So, and that's it. So now if I want to invoke it, all I have to do, just write response here, response, and equals to llm.invoke, and I can just say what's the type of this and call response. That's all I need to do, right? This application will work, right? But this is one way of doing this, but there is another way. Okay, let me run this one. Okay, we got the answer, which is Paris. Okay, so the capital city of France. But let's say I don't want to use init chat model. I want to use something else. Okay, the reason I'll tell you why we will use this one, because this will simplify many things for us. Okay, right now let's say I want to add tools for this application. Okay, what I have to do if I use this init chat model, I have to define tools this way. Okay, I'm going to go def here, let's say get weather. Okay, I have to do it this way, weather, and I have to go here location. Okay, and I have to do this one. Okay, and I have to define this one. This is how we define tools. Okay, this tool basically is going to return the weather for any location I put. It will return the weather is sunny, the weather in New York or whatever is sunny. Okay, and this is what we call by this is very important. This is what tells the LLM what this tool will do. Okay, that's why we mentioned this. The job of this tool is to get weather information based on location. Okay, Now what I need to do here is actually I'm going to bind it. Okay, I'm going to mention here llm underscore width tool. Okay, and I'm going to mention here llm dot bind tools get weather. Okay, I have to do it this way. Okay, so I will bind this tool with the llm. Okay, then in order to get the response, I'm going to go ahead and do this one. Response equals to llm with tool dot invoke and invoke and what's the weather for New York. But this has okay, and this actually is going to work, but it's not going to give us the response that we are looking for. Okay, this actually, because we have to call it, we have to mention here response, and then only we can do it. This is one way of doing it. Okay, it's just going to, but it will get the location, the details, but the content is not going to display for us. We have to do additional steps to do this. There is more we need to do. Okay, so this is like the hard way, okay, of using tools, connecting your LLM with tools. There is a simpler way of doing this. Okay, I will do it now. Okay, I'm just going to remove this one. Okay, remove it completely, and let me do it. Let me show you. So we will use something called agents. Langchain. This one will simplify our job significantly. Langchain import create agent. Okay, so now I'm just going to type here agent or LLM, it doesn't matter. This is just whatever, right? Because I'm just going to name it agent. Okay, now I'm going to say create agent. Okay, I'm going to define the model here, which is equals to GPT-5, and I'm going to find the system prompt here. That's all I need to do. Okay, and then I'm going to add the tool here. Okay, let me write our tool here, which was here, right? Tool. It was def get weather, right? So yes, so this is it, and this is it. So here all I have to do is just add here tools equals to get weather. That's it. No more doing this extra steps here. That simplifies the job. Now all I have to do to code it, I'm just going to type agent here. Okay, sorry, response here, and I'm going to mention here equals to agent dot invoke. Okay, and I'm going to mention here message. This is the syntax. You have to always remember this syntax. And the role means who is submitting this, the user. Okay, then you just put comma content, this one, and what is the weather in New York. Okay, now let's just type response, and we will get the, let's do response.content, because that's what we want, right? So let's try to run this one. There's a mistake, because yeah, this one, the message has to be under double quote. Actually, it should be in double quote. This was the issue. Now let's run it. Okay, this is the issue. Actually, no need to, just put it display as a response. That's it. Okay, so now you see what we got. It's already, we see how our response is. It's saying the weather in New York is sunny. Okay, the weather in New York is sunny. Okay, this is it. We got the tools message. Okay, and the AI message, the New York, the weather in New York is sunny. Okay, if you don't use this tool, okay, if you don't connect the tool, it's going to give you, I don't know. So this is a simpler way of using connecting the agent with the tool. Okay, so now that we know the tools, let's read something about tools. The tools. I don't have much here, but tools basically I didn't mention much here, but just remember this is the way to add the tools. It's very simple, and we can check the docs actually. If we want more information about this, we can just go to the Langchain docs, for example, and we can, let's see, learn here, and we can go ahead. No, we want to learn Langchain, right? But Langchain, yes. So this is it. So the tools, you can see it here. Tools extend what the agent can do, letting them fetch real-time data, execute data query, and external data, take action. So basically, tools are callable functions under the hood. Well-defined input and output gets passed to the chat model. Okay, so to create tools, the simplest way to create tools is using this tool decorator. Okay, like this. This is what we use, right? By default, function docstring becomes tool description. Helps model understand when to use. Docstring is this one. Okay, well, this is we add this for the model so that it can understand. Type hint required to define. Okay, so customize tool properties. You can, by default, tool name can be a function name. Okay, custom. You can give it a custom name like this with this one. Custom description if you want. So define a complex pedantic model. Pedantic model, we will go through it. Okay. To access a tool, we can use this one. So all this stuff. Okay, basically that's what we need to know about tool, how to connect tools. Next, actually, is the messages. Okay, we have two types of messages. Okay, let me show you an example. Okay, practical so we can see it. Not two, I mean 4 types of messages. You can see it here. We have the system message, which is the one that I provided. This is that's a prompt that we give to the AI. Okay, tool message. This is the message from the tool. Okay, and AI message. This is the answer, the message from the AI. Okay, there are different types of messages, and how we can define them is from here. Look, from Langchain here. You can just go here dot messages and import system message and human message. Okay, this is one thing of doing this, and you can just you can use let's use this one in it. That's fine. Just type LLM here and in it. Yes. Actually, you have to change the provider because the provider is OpenAI for GPT. It's not Gemini. So let's just fix it, and let's just close here. Okay, we don't want any tools. We want to see the messages. So now invoke. Yeah. So this is it basically. So now you see this response. I mentioned here LLM invoke system message, put the content to our helpful assistant that provides contact information. And human message, I mentioned here what is the contact number of Jane Doe. Okay, now if I run a response, okay, it's going to give me the answer. So the idea is the system message is actually for the LLM, what we are giving it. Okay, the prompt. Okay, the human message is the user's message, like the human's message. So this is the response we got. From the AI. As its simplest, artificial intelligence is a subfield, computer science. Okay, this we are getting this kind of answers because actually we need to. It's running all. 1 second. Let me remove this one. Remove this one. Remove this one as well. No, I removed the. Yeah. Remove what we don't need because it's actually making. It's a lot, and I don't think we need it. Okay, we don't need this, and we don't need this. So this is what we need. So let's run this one. So we can actually see the theory here. We have three main types of human message. This is the user input. This is what you send to the model. Okay, we can just say like content. What's AI? This is the user questions, prompt, and instructions. AI message is the model response. This is what the LLM returns. Okay, like AI is the field of computer science and stuff. And it's hallucinating again and again, but for some reason it's hallucinating. Okay, so actually it's my mistake. I think I am not putting the correct response here. It should be response. Okay, so yeah, so the answer is the AI message. Content Jane Doe is a common placeholder name. Could refer to many different. Could you share more details? I could later go home. Yeah, so but it understand what's the question, right? It received the human input and it understand the task, the prompt. So the idea here is very simple. What we need to know from our side is the system message, the rules and behavior. The system message is basically how the AI should behave. Okay, and we have also role. This tells who is speaking, like user, whether it's system or model, assistant, whether tool, right? So yeah, so the content, this is the actual text or data. That's why I mentioned content here. What's being said or returned. Metadata is hidden information about the message, not the message itself. Okay, like model name, token usage, tool, call, all this are metadata. This extra information we don't really need, right? Are used tools related to metadata, like we have content, tool, calls, name, get weather, arguments, location, Paris. This are like tool related metadata. Okay, and tool call ID is a metadata that connects tool. Okay, so this is basically how it will look like. Okay, and that's it for this topic. We want to try pedantic and data classes. No, let's just try pedantic because this is very important. Okay, now no, before this we have to know that's how we will do pedantic. Okay, and in order to make pedantic work for you, you have to add it here. UV add pedantic. Okay, pedantic is like basically Zod or TypeScript. It's used for validating the type and structuring the output. Okay, so it will be, you can define how you want the output to be. Okay, let me go ahead and do it again. Okay, from pedantic import base method. Okay, you have to import base method model, then class. I'm going to mention here contact information because I prefer to use contact information. It's much simpler. Then I have to mention, you put here the base model. Okay, the one that I imported. This is important. Okay, and then I'm just going to mention the fields. So name, I'm going to say string, then I'm going to say equal, then I'm going to add field. I have to add field here actually, comma, field. Okay, field will give me more options. Okay, and then I can add like this. Okay, you can mention here description. The description, I want it to be this is the name of the contact. This is a good description for this. And comma, now the number, and the same, no, number is not a string, right? It's an int, I think. Equal field, and I'm going to mention here this description, and equals to, this is the number of the contact, right? And one more, email, I'm going to mention here string equals to field. This is the email of the contact. Okay, so now that we have done this, okay, let me input the from Langchain dot chat models import chat, no, init chat model, right? So let me just put LLM here equals to init, yeah. This is actually 3.5, not 3.5, we're going to use GPT-5, I think. Okay, so now what we need to do is put here LLM, no, structured LLM underscore LLM. Okay, then here I'll put LLM dot with underscore structured underscore output. Okay, we have to memorize this stuff, and then we're going to mention the name of the class, contact info. Okay, so now we just put response, and we mention here equals to structured LLM, and what is the contact information of Jane Doe. Okay, that's it. So if you run this one, okay, print response, you're going to get the name, the contact, and this format. Okay, using this type, and also the format will be like this. Okay, this fields, to input this fields. Okay, so this is what we did. Now let me go ahead. Configurable object not callable. Yeah, because I didn't use invoke here. You have to use invoke always when we want to call. You have to use invoke. Model structure dot invoke llm.init and with structured output. Wait, something is wrong here, but 1 second, let me try to see what exactly is the issue. Type error init chat model, missing one argument, positional argument model. LLM with structured output. I think maybe there is an issue with the syntax. Let me see. With no, it has to be structured output actually, and we choose LLM here. Correct. Structured LLM dot invoke, and let's see. No, okay, we can go ahead and we have an example of pedantic here. We can go and check the documentation just to verify. Here we have structured output, right? Okay, structured output allows agent to return data in specific predictable format instead of parsing natural responses. You get structured in the form. So this is the benefit of structure basically. Langchain create agent handles structured output automatically. The user sets the desired structured output when the model generates the structured. Yeah. So response format, we have provided strategy. So this is a different way of doing it actually. Okay, and I didn't use create agents. This is a different. Using create agent is other way of doing it. Let me go ahead and let us just copy this one. Okay, it's actually the same example. This is it, and this is just so all I have to do is connect this one, and if I'm going to do this, all I have to do is just add this one. If I'm going to use agent basically, okay, all I have to do is just add the response format, contact info. It automatically selects the provider. This makes it much simpler than what we are doing right now. And then and then you just print result structured response. Okay, this is actually much better. Okay, let us use this one. Response format equals, okay, let us try to use this one. Okay, let us use agents. If you're going to use agents, we can just remove this one. We don't need to use this one. Okay, and Langchain dot agents. Okay, import create underscore agents, and here I'm just going to type agent equals to create agent. No need to put LLM here. Go down and type the GPT-5 here. Okay, and this is the model, right? So the model is GPT-5, and here we just have to add the response format, response underscore format. Okay, it's going to be contact information, contact info. This is our class, right? But we have to cancel this, put it below this one, I think, and put comma here. Okay, so we added create agent, import create agent. Okay, so we don't need to do this. We don't need to do any of this actually. Okay, so what we need to do here is just agent can put response here, okay, equals to agent, and we're going to do dot invoke, okay, and then we're going to do message, and after that you're going to put this, and you're going to add the role here, and then you put the user, and then you add the content, and what the information. No, yeah, this is basically what we will do. And here we're just going to type the response, and we have to mention here the structured response, right? Structured response. No, just structured response. That's it. So basically this is it. Okay, you can go ahead and run this one. It's mentioning what was the error. Let me see what was the error exactly. Pedantic user error, non-net utter was detected. Agent Landgraf is not. Okay, I'm not sure exactly what's the issue now, because I think we did exactly as it's shown on the documentation. Structured output, we put it here. So I did this. Oh, okay, wait, I think no, I don't think that's the case, because I did already. Okay, so base model, the spelling, everything is okay, and we added the create agent response format, and then we invoked it the right way, and we just need to print, I think, print structured response. So just put it print here and see what happens. Print. Yeah, and also let us add some some information for the agent. I think this is good practice, and now let's go ahead and run it. Pedantic user error, non-native agent Landgraf. Let me see this. I think this has to do with the import agents pedantic. I have imported pedantic as well. Everything was I did it as per the contact info class, contact info, and the quotes is there. So basically this is not working for some reason I'm not aware of. 1 second. And non-annotated attributes was detected. Agent equals to this, and all model require type. If agent is not meant to be in the field, to be a field, you may be able to reserve by annotation it to class var. This has to do something with the fields, I think. Here I mentioned the name, number, and okay, so this was the issue. No, not this actually, because I already closed here. Let me see what was the issue. Type annotation, base model, what was the contact, structured. Let me copy their code and see what happens. See what will be if we just copy and paste it their code. I think yeah, their code is working fine. So what was the issue? Okay, I think it must be the content, because the content here I put the content, yeah. It's the only explanation here, because structured response, everything was done actually the dots, I think, for that. Anyways, this is how we can do. I hope you got the idea on how to, and if no, you can go through this one. And there is one more concept that I think we should cover: short-term memory. Okay, short-term memory, and we understood how to do this, how to do Langchain. Okay, now let's just have a look at short-term memory. Memory is a system that remembers information about previous instruction for agents. Memory is crucial because it lets you remember previous interactions, learn from feedback, adapt user. So that's basically the benefit of memory. And memory, you can add it here. See, under tool, if you're using agent, you can just put here check pointer equals to in memory saver. Okay, but you have to import this one, memory saver. So to add short-term memory, you need to specify check pointer when creating an agent. So this is check pointer. So this is you add it here, and when you call it, you just add thread ID 1. In production, use check pointer backed by a database. Okay, this is how we use it in production. We just add a check pointer when we create there. And customizing agent, by default, agent use agent state to manage short-term memory, specifically conversation. Extend by add additional fields like this one. Okay, and short enabled long conversation can exceed the LLM context. With the common solution, we have trim, delete, summarize messages, all this stuff. So this is a way to trim messages. Okay, and there is one more thing that we need to understand. The middleware provides a way to more tightly control what happens inside the agent. Basically, middleware is useful for the following: tracking agent behavior with logging, analytics, and transforming point. So middleware is just what you put inside. It will be in between your LLM and your the user, or between the LLM and the tool. It's going to sit between them. For example, we have here summarization middleware. Okay, let's choose. Let's see, no more tool. Middleware exposes hook before and after each of this step. Okay, the core agent loop involves calling a model, letting it choose tool to execute, and then finishing when it calls no more tool. Middleware expose hook before and after each of this step. Okay, it can sit before the agent or before the model. Okay, before the model or before the agent. Okay, use middleware inside LangGraph workflow. Middleware are not separate runtime. Hook run inside the compiled run create agent. You can drop the whole agent middleware state graph. So this is this is an example. This is an email agent, for example. Okay, we add a middleware here. We put a human in loop middleware. Interrupt on send email equals to true. Okay, so let's say we have a graph here, summarization, and there are different let's see, pre-built middleware. Okay, these are different middlewares. So we have summarization middleware. This automatically summarizes conversation history when approaching a token limit, basically. Okay, human in the loop pause execution when human approval or tool calls, like when you need human. So let's see summarization. Automatically summarize conversation history when approaching token limit, preserving recent messages while compressing older context. Summarization is useful for long-running conversation that exceed context window, multi-turn dialogue, application yeah. So for example, this is what we do. We use summarization. We just add middleware inside the agent. We add summarization middleware like this model, and define a model, and we define the trigger. This is very important, where we put tokens here. If the token reaches 4,000, okay, keep messages. So this is what happens basically. Okay, so full example here. Okay, so multiple trigger if numbers of token is greater than or equals to 3000. Okay, yeah, so it will summarize the thing. Okay, same thing with human in loop. Dispose agent execution if the if you it will stop if there is an action that requires human execution. Okay, that's the idea of this. But we can check this one now. Okay, this one we can just add this middleware itself here. Okay, these are the tools, these are the way of doing it. It's very simple actually. Okay, and I think that's enough for Langchain, because the reason we're learning Langchain is because to learn something, to learn long graph. Okay, because that's our goal. We'll start long graph tomorrow and we'll go into more details there. Okay, I think we should cover two more topics. So right now we didn't cover until we forgot to cover this one. Batching and streaming. What I just did. Okay. Basically, streaming means the AI sends a response token by token. Okay. And word by word. Okay, chunk by chunk, instead of waiting for the full answer. That's the idea of streaming. Okay. Streaming matter. Without streaming, then if you type, let's say you use this one. Okay. The user will have to wait 5 to 20 seconds before seeing anything, any response. Okay, but if you use streaming, okay, the user immediately sees output. Okay, this improves UX, responsiveness, chatbot, all the stuff. That's the idea of streaming. This is the commands, very simple. For chunk in LLM stream, what's the capital of France, and it's going to give you the response fast. Okay, you will see the response immediately. You don't have to wait until the AI figures out the full answer. Okay, and batching is basically when you want to send multiple inputs to the model at once instead of one by one. Okay, without batching, for example, let's say you have 3 questions. Okay, for questions print LLM, so it will take too much time. Okay, also many API calls. It's inefficient, right? But if you use batching like this, okay, so it will be faster, throughput, scalable, and API efficiencies. Okay, so basically that's what it means, and we can try 1 or 2 examples here. Okay, let me just remove this one. Okay, I'm going to go ahead and type from I think it's time we just use agents, Langchain dot agents, and import create underscore agent, and yeah, so I'm just going to create agent here equals to create agent GPT. Remove this stuff because we don't need it right now. We don't need any of this. We don't even need this verbose stuff because we just want to test right? So we don't need anything. And then I'm just going to click agent. First let's test the streaming. Okay, so the streaming is just going to be like this. Response is equals to, no, let's just type, response is equals to agent dot invoke, right? What is the capital of France, right? So the response is supposed to be for R and response. Okay, no, it's supposed to be it's supposed to be dot stream, I think. Agents dot stream, not invoke, dot stream. Okay, agent dot stream, print. No, it's supposed to be for R and invoke. Let me see. Let me go back here. Streaming. We've said we have this example we created for streaming. This one basically. Use this one. This for streaming. Okay. What we did here is basically for chunk and chunk is just a variable. Okay. LLM we mean basically agent basically. We mean agent.stream. Okay. Agent.stream. What's the capital city of France? It will loop the chunks of content. Okay. It will give you the answer. Okay. Let us go ahead and run it. We got an error because expected this scenario. What's okay? Because it's difficult to do it with agents actually. So let me go ahead and just do it from Langchain dot chat models. Okay, import init underscore chat underscore model, and let me go ahead and just change this one. Yeah, change this one to this, and now it's going to work. Yeah, Paris, because there's only one response here. But if we say, let's say, explain AI. Okay, now let's see the response. See how fast it's giving us the answers. See, it's giving us the answers as it's getting it. Okay, so this is basically the benefit of streaming. Okay, there is one more thing we call it bulk batching. Okay, to test this I have to remove this. Okay, I have to create a new variable. Let's say questions here. Questions equals to, I'm going to put it here, put the first question here, second question, 3 questions here, right? So I'm just going to put the questions here, and yeah, so let's see what it will do. It will give us the response for these 3 questions. It will run it all, both, because I'm using batch here. Okay, that's what we call batch. Paris, my knowledge is current through October 2024. At that time, the US president was Joe Biden. The presidency was after have changed for the most current answer. Yeah. So these are basically the largest amount. So it gave you the answer. Because it batched the questions. Okay, that's the idea. That's the benefit. And thank you.